Over the past few years, you've heard us talk a lot about how Google Cloud is built on top of our global network infrastructure. This year, we wanted to take the opportunity to dive a bit deeper into this aspect of the network design, of that of being global, and also talk a bit about how it enables features in global virtual networks, or VPCs, and hopefully encourage you to think big and to think global when you're planning for your own application deployments. We have a 50-minute talk today. My name is Neha Pattan, and I'm a software engineer at Google. I'm going to be joined by Marshall Vale, who is a product manager on the Cloud DNS team, and by Ed Hammond, who is our guest from Cardinal Health. He's a senior enterprise architect at Cardinal Health, and he's going to be sharing with us Cardinal Health's deployment of VPCs. So this is what cloud basically consists of. Cloud is divided into multiple regions, and each region is divided into zones. Now, a region is basically a geographic location where the round trip time, or the RTT, from one machine to another is typically less than 1 millisecond. A region is divided into 3 or more zones in GCP, and a zone is basically a geographic location where the which is fully isolated and which is an independent failure domain. So no two machines that are in different zones or in different regions will share the same failure domain. We have 19 regions and 58 zones in GCP today. So how does Google's network infrastructure power this? Now, Google's network infrastructure basically consists of 3 types of networks. The first is the data center network, which connects all the machines in a data center together. The second is a software-based private WAN called B4, which connects all the data centers together. And then we have a software-defined or SDN-based public WAN that we call B2 for user-facing traffic that is entering our network. So every machine in the network basically gets access from the internet through B2, which is our public WAN, and gets access to other machines in other data centers through the private WAN, which is B4. Now, one of the things that are worth mentioning here is that we, in addition to the peering routers, we also deploy network load balancers and layer 7 reverse proxies at the edge of our network. And what that helps us do is to terminate the end user's TCP or SSL connection closest to the end user. Now, as you know, establishing an HTTPS connection requires 2 network round trips between the client and the server. And so it's really important to reduce the round trip time between the client and the server. And the way we do this is to bring the server closer to the client. And so we basically have the layer 7 reverse proxies deployed in the edge locations. These proxies also help serve cached content. And you get access to this cache when you enable Cloud CDN on your load balanced applications. So this is what basically comprises the Google Global Network, with 134 network edge locations, presence in over 200 countries and territories, and content delivered through Google CDN. You get access to the same functionality that also powers the rest of Google services like Search, Maps, Gmail, and YouTube. So this is basically what Google Cloud footprint looks like right now. We have 19 regions. We've also announced 2 more regions that we are turning up before the end of the year, and we have also announced 2 more regions that we'll be turning up in 2020. We have 134 POPs, or points of presence, and 96 CDN locations. Our data centers are connected worldwide through hundreds of thousands of miles of fiber optic cable. We also have 13 subsea cable investments. We have 81 dedicated interconnect sites. So these are basically locations where you can directly peer with us, and you can use dedicated or partner interconnect. So why is all of this important to you? Why do you care about having a global network? Now, if you were to deploy your application, you would deploy it to multiple virtual machines in a single zone. And the reason for doing this is to protect yourself against single machine or single VM failures. Similarly, in order to protect yourself against single zone failures, you can replicate your application across multiple zones in a region. And this gives you added redundancy and hence more availability for your application. Now, in order to protect yourself against single region failures like natural disasters or other such rare events, you can replicate your application across multiple regions. So you can have a global deployment. And the advantage of that is also that you'll have compute machines that are closer to the end user of the application. And so your end user will have a better user experience. So basically, having more redundancy increases the availability of your application. And so having multi-region and global deployments is actually really important. The key point here is that with global deployments, you are able to access all of your compute and storage resources privately and globally, and the traffic never leaves our network backbone. So it basically doesn't transit over the internet. So all of your compute and storage resources you can access globally and privately, and you don't need to assign public IPs to your virtual machines, and you don't need to set up expensive VPN or peering connections between regional VPCs. Another advantage of using a global network backbone is that you can enable global load balancing. Now, global load balancing basically allows you to have a single global IP address for your load balanced application, and you're ensured that the traffic is served by the closest healthy backend to the end user. It's a little difficult to view on this in this presentation mode, but you can see here that there's a user in Texas, and then there are users in other parts of the world. And the user from Texas is basically routed to the closest healthy backend to their location. The user from Texas and the user from anywhere else in the world will see the same global IP address for your load balanced application. Now, if the user in Texas is basically routed to a backend that is running in Portland, Oregon, but if there are no healthy backends running in any region in North America, then they may get routed to the next closest healthy backend, which may be in a different region. The important thing here being that their TCP or SSL connection is terminated closest to their location, so somewhere close to Texas. The request is then encrypted and then routed over the network backbone to the correct data center running in the next closest region. We use the same DDoS protection system in cloud as we do for the rest of Google, and so you benefit from the same perimeter security that we apply for other Google services. We'll be discussing Cloud Armor in a little bit, and Cloud Armor is basically a product that allows you to customize rules that you want to define at the perimeter of our network, and those get applied at the edge of our network for your load balanced applications. Now we are able to assign a single global IP for your load balanced applications because we use stabilized Anycast. Anycast, as many of you may know, is a routing and addressing methodology that allows us to route datagrams from a sender to the closest receiver among a set of multiple receivers that are all programmed to serve traffic on the same IP address. Stabilized Anycast basically allows us to stabilize the TCP session despite BGP instability. So if your ISP is basically reconfiguring the prefixes that they are advertising over the internet, then there may be some amount of route flapping that happens. And in such a case, a client's request may reach a location that is not closest to them. What happens in such a case is that when the network load balancer in that location receives the request, it finds out that the client IP is actually closer to a different location, and then forwards that request to the network load balancer in that location. The request then gets correctly routed to the correct backend. So this is how we implement stabilized Anycast. So that was all about the physical network. How do these things help with virtual networks? Now, as you know, virtual networks in Google Cloud are global in nature. So you can create a network once, and you can associate network policies with your network once, and they will just work with VMs that you create in new regions. So you can create policies like firewalls and routing policies, and these will just work as you add more regions to your network. If you're an enterprise administrator, then you can use shared VPC to centrally create and manage the network in your organization. And you can scale your organization to hundreds or even thousands of developers or development teams, and you can give them full autonomy in creating their compute resources while they attach those compute resources to the centrally shared and centrally administered network. So let's say you have a shared VPC setup. where you would like to create in your organization two types of applications. One is an internet accessible application, which is a web app. And the other is an internal application. Here, the example is that it's a billing application, and you would like to have the web app service use the billing service internally. So with shared VPC, you can create a load balancer in your web app project. For reasons that we discussed earlier, you will want to enable more redundancy, and so you create compute resources in multiple regions. And then you can set up those VMs as backends to your load balancer. Then you can create internal load balanced applications in your billing project, and your web app backends can then access these internal load balancers. So this is how you can create multiple tiers of applications in your shared VPC. You can then associate firewall rules with the VPC in order to restrict traffic within the VPC. Now, due to the global nature of our network, you also get access to Google-managed API services like cloud storage, machine learning, big table, spanner, and many others. So you don't need to assign public IPs to the VMs in order for you to be able to access those services. Now, one of the things that we have done over the past year is extend this functionality of private access to Google services to your on-prem network. So you're able to privately access Google-managed API services from your on-prem via VPN or interconnect as well. Now, in order to secure your VPC, you have multiple options. You can use network layer firewall rules, and these are stateful and connection tracked. You can specify your firewall rules as either allow or deny in the ingress or the egress direction by specifying source or destination IP ranges, respectively. Firewall rules allow you to easily group your VM resources using tags or service accounts. Now, if you're troubleshooting an issue in your VPC and you would like to find out what the effect of a firewall rule is, and you want to root cause whether this firewall rule is causing an issue in the VPC, then now you don't need to delete and recreate the firewall rule in the VPC. You can simply disable and then re-enable that firewall rule. Another new feature that we have GA'd over the past year is firewall logging. Firewall logging basically allows you to view reports of connection records that get created every time a firewall rule gets applied in your VPC. Firewall logs are not sampled, unlike VPC flow logs. And so there is a limit, though, on the number of connection records that get exported in a 5-second interval. And this limit basically depends on your machine size. You can export firewall logs to Stackdriver, Cloud Pub Sub Storage, or BigQuery. The firewall logs are basically created in your shared VPC host project so that the security administrator of your organization can view, analyze, and verify that the firewall rules are enforced correctly. So as I mentioned, the firewall, a connection record in a firewall log basically gets created every time a firewall rule gets applied. And so for VM to VM traffic, a connection record will get created for the egress rule that gets applied on the sender VM and the ingress rule that gets applied on the receiver VM. This is the same for VM to VM traffic across shared VPC service projects, as long as they are in the same VPC. And this is also true for traffic that is entering or leaving your VPC, either to go from or to the internet, or a peer VPC, or the on-prem connection from a VPN or an interconnect. If you would like to apply policies at the edge of our network so that you are basically ensuring that rules are applied for traffic that is entering your load balanced applications, then you can do this using Cloud Armor. This is also something that we have GA'd over the past year. So let's say you create a load balanced application in your project and you assign virtual machines as backends to your load balancer. You can then associate security rules using Cloud Armor to your load balancer. And the traffic that is allowed into your load balanced application will then conform with these rules. So you can specify rules like IP blacklists or whitelists. This is now generally available. You can also specify geo-specific rules or WAF rules. Or you can also use a flexible rules language, which allows you to customize and specify fine-grained rules for your security policies. So what does a typical deployment look like? So in a typical deployment, let's say you create your global HTTP or HTTPS load balanced application. Now, as I mentioned before, because we use the same DDoS protection system in the cloud as we do for the rest of Google, you will automatically get defense against DDoS attacks. If you would like to customize this further, you can create security policies using Cloud Armor and associate these with your load balanced application. If you would like to enforce policies where you are allowing access to your application only if such access was permitted using IAM policies, then you can use a product called Identity Aware Proxy. So this is Cloud IAP. Now, traffic is basically permitted into your load balanced application. It will enter your VPC only if it is allowed by both Cloud Armor as well as IAP. At the VPC level, you can specify network layer firewall rules that allow traffic only from the load balancer proxy. And so you don't need to open your VMs or ports to all of the internet. Another important aspect of designing security in your organization is ensuring that you mitigate the risk of data exfiltration. You can do this now using VPC service controls, where you're able to define the service parameter, which is also a security parameter for your data and for your compute. With the extension of allowing private access to Google API services from on-prem, you're also now able to extend the definition of your service parameter to your on-prem. So that brings us to the next question. How do you access on-prem? Now, there are multiple ways of connecting to your on-prem network. You can either use VPN, which also allows you to specify two methods. You can either use VPN with static routes, or you can use dynamic routes using Cloud Router. And the other method is to use interconnects, where you are directly peering with us, or you can use partner interconnect, where you're paying a partner for directly peering with us, and you're paying them for the bandwidth that is used. You can create VPN connections or interconnect attachments in your shared VPC host project, and you can connect those to your on-prem network. When you do that, all the VMs in all the service projects in that region that are attached to the shared VPC host project will be able to get access to your on-prem network via those VPN or interconnect attachment connections. Now, another feature that we are really excited to announce the availability for is the option to create highly available VPN connections. Now, the way you would do this is you would create two interfaces on your VPN gateway, and you would connect from your on-prem to both these different interfaces. Each of these interfaces would get a different IP address, and due to this, you basically get a redundant VPN tunnel to your on-prem. You can set up your highly available VPN either in active mode, in which case you're actually advertising the on-prem prefixes using the same med value, or you can use it in active passive mode, where one of the tunnels is used as the primary and the other is used as a backup. Another feature that we launched to GA over the past year is Cloud NAT. Now, Cloud NAT is basically a managed NAT solution that allows you to configure internet connectivity to your VMs without having to provide public IPs to those VMs. Now, NAT is a really, it increases the security of your VPC because you're assured that connections to your VMs cannot be initiated from the internet. And this is because Cloud NAT basically implements outbound NAT. It doesn't implement inbound NAT. Cloud NAT also scales seamlessly across VMs and across connections by managing both static as well as dynamic IP allocation. So NAT configuration can also be done in the shared VPC host project. So let's imagine that you have a package server on the internet that you would like to download packages from onto your VM machines in order for them to bootstrap. Once you configure the NAT configuration in the shared VPC host project, all the VMs and all the service projects in that region will be able to access the package server or other things on the internet using the IP addresses that are now managed by that NAT gateway. One thing to mention here is that NAT is a control plane component. It's not a proxy-based solution. And so you get the same performance and the same throughput for your internet connection as you would if you were to give your VMs public IPs. Now, if you assign public IPs to your VMs primarily for internet connectivity, but you also had the advantage of being able to SSH to your VMs, then you lose this capability of being able to SSH to the VMs when you remove public IPs from the VM and use Cloud NAT instead. And this is mainly because, as I mentioned before, you cannot initiate a connection from the internet to the VMs that are managed by NAT. So in order to be able to SSH without having to assign a public IP to your VMs, you can now use Cloud IAP. We talked a little bit about IAP, or Identity Aware Proxy, in the context of global load balanced applications. The functionality of IAP is now extended to also do TCP forwarding, so that you can specify IAM policies on who has SSH access to your VMs, and then you can SSH to the VMs using Cloud IAP TCP forwarding. So what that does is it wraps the SSH connection inside HTTPS, and then using TCP forwarding, it sends that to the backend VM. Now the next thing is that of accessing managed services. Now if you would like to connect two VPCs in two different organizations, then you can use VPC peering. You can also use VPC peering to connect two VPCs in the same organization if you would like to separate out the network administrators for the two different workloads. We're really excited to announce that private service access is now generally available. Private service access is basically a managed solution that allows you to create a private connection to a managed service. Another cool thing that you can do with private service access is that if you're a consumer of the managed service, then you can carve out a global IP range and you can hand this off so that every subnetwork that gets created in the producer's VPC is created out of this global IP range. So that way you can actually plan your IP ranges much easily. Another thing that we have done over the past year is we have extended the functionality of VPC peering to the on-prem network. So you're now able to access your managed services via VPC peering from your on-prem via VPN or interconnects. Another really important feature we have added to VPC peering is the ability to control custom routes that are exchanged. So let's take a look at that in a little more detail. So let's say you have two VPCs. The VPC on the left is a consumer VPC, and the VPC on the right is a producer VPC. Now, the moment you pair these two VPCs together, every VM basically gets connectivity to every other VM. So your managed service instances are accessible from VMs in different regions, as well as VMs in different service projects. So let's say you have in the consumer VPC a routing table where you can see the local routes for the local subnets. You can also see the peer route for the peer subnet. And let's say you have added two more static or custom routes in the consumer VPC. One of them, the first one, the 10.4/16, is configured to go to your on-prem via VPN. And the second one, 10.5/16, is configured to go to a VM instance, and maybe you're running an appliance on the instance. On the peer side, that is in the producer project, you can see the default local route for the subnet in the producer VPC, and you can see the two peer routes for the subnets in the consumer VPC. But the custom routes are not visible by default. With custom route exchanges, you can now enable export on the consumer VPC, enable import on the producer VPC, and the routing table in the producer VPC is now able to see the two custom routes that have been added in the consumer. You can either disable export of custom routes from the consumer VPC, and this removes the custom routes from the producer's routing table, or you can disable import, and this has the same effect. Both export of custom routes and import of custom routes are disabled by default. So in order to exchange custom routes, you need to enable export on the sender VPC and enable import on the receiver VPC. The last topic that I'll be talking about is VPC flow logs. Now, VPC flow logs are a feature that we launched to GA over the past year. We have enhanced the functionality of VPC flow logs to allow you better control over controlling the flow log size. So now you can control the aggregation interval, and you can configure this. The default is actually 5 seconds, and you can configure this to be anywhere between 5 seconds and 15 minutes. You can also configure flow report sampling. So sampling for VPC flow logs by default is 50%, but you can change it from 0 to 100% now. And in addition to that, there are certain metadata that get added, like geo-specific annotations or other kinds of annotations that get added to VPC flows, and these can also now be disabled. So this helps in restricting the size of your VPC flow logs. And now I would like to invite Marshall on stage to share with us a few announcements on Cloud DNS.
Thank you, Neha. My name is Marshall Vale. I am the Cloud DNS product manager. And of course, one of the critical components for connecting your resources in a VPC is, of course, DNS, or the domain name system. So today I want to give you a brief overview of Cloud DNS services for your VPC, including a couple of exciting announcements. So first off, Cloud DNS private zones are able to provide an internal DNS resolution service to your private networks. This is important as internal resolution to just your internal networks helps exclude external parties from discovering information about your internal networks through DNS. A Cloud DNS private zone can be connected to a single or multiple networks in your VPC. It also is able to support split horizon, which allows you to have the same zone available in the private and public environments. And you might use that, for example, you might have a package server that it has internal information and external information, and the internal information would be additional software packages, and you want to be able to access those additional ones through the same scripts. Private zones also support IAM policies, so you can delegate administrative and editor and viewing capabilities for your zones. And private zones are also currently in general availability, so we're really excited about that. Also really excited to announce that we are today introducing Stackdriver logging and monitoring for private zones. That allows your private zone queries and monitoring information about your responses to be stored into Stackdriver. And from Stackdriver, you can either store them long-term, or you can transmit them with Stackdriver PubSub to other storage facilities, such as BigQuery, or even onto your on-prem storage solutions for further analysis. Your query logs are pretty standard bind style logs, where you have information such as QName or RData. Your monitoring responses will be able to do counts for traditional responses like a serve fail or NX domain. This is really important for debugging your private zones, but also is used as a strong signal for your security threats that may be on your network. Now, you'll be able to use private zones for your just internal VPC needs, but you're also often connecting your VPC to other VPCs or even to on-prem environments. To support your on-prem connections, we have the DNS forwarding capability, which supports bidirectional DNS traffic between GCP and on-prem. For DNS outbound forwarding, that allows your GCP resources to use a forwarding zone to use a on-prem authoritative server, such as Active Directory or Bind. DNS inbound forwarding does the vice versa. It supports your on-premise resources to use GCP Cloud DNS as your authoritative server. You can learn a little bit more about hybrid connectivity and DNS forwarding in particular at the Net 204 hybrid connectivity session tomorrow. DNS forwarding is available today in public beta. Now, you may also be wanting to connect between VPCs, and for that we're introducing today DNS peering. This is a new capability that extends DNS traffic between your VPCs. Now let's look at a couple of common scenarios. So one is you may be a SaaS software provider and you want to connect your customers' VPCs into your service provider network. So on a consumer side, they would create a peering zone and connect it into the service provider's network. that network would also have a private zone associated with it. From there, the consumer is able to resolve DNS from the SaaS provider's DNS zone. You may also be wanting to connect multiple VPCs to an on-premise DNS authoritative server. For that, you would have a single VPC hub, which would provide the forwarding to on-prem, and then spoke DNS peering, spoke VPCs that are DNS peered into the hub VPC. Now, DNS peering does not require that your VPCs be peered. It actually uses the DNS infrastructure to transmit the packets. DNS peering is available today in public beta. So with that, you can see there are a variety of cloud DNS services that support the flexibility you need out of your VPC architectures. With that, I'll pass it back to Neha real quick for a kind of summary of what you've heard today so far.
Thanks. There you go. Thanks. So just to summarize the brief, to summarize briefly the takeaways that we want you to remember from this presentation. The first is that network, the virtual network is global in nature. So you can configure your network once and you can manage it centrally using shared VPC. Security comes first with Google Cloud in general and with VPCs as well. You can specify network layer firewall rules for security within your VPC. You can use Cloud Armor in order to specify security policies that get applied at the edge of our network for your load balanced applications. And you can also use VPC service controls in order to ensure that your data and your compute are mitigated against data exfiltration. And lastly, with the integration of VPC features with stack driver logging and also with VPC flow logs and firewall logging, VPCs are now really easy to monitor. And so hopefully you have a really good time using VPCs in the cloud. And with that, I would like to invite Ed on stage to share with us his story of using VPCs for Cardinal Health. Thanks.
Thank you, Neha. All right, so I'm Ed Hammond with Cardinal Health, Enterprise Architect. If you don't know anything about Cardinal Health, it's a healthcare logistics and manufacturing company. We are based largely in Dublin, Ohio, Columbus, Ohio, but 50,000 employees globally. So when we started looking at Google and we started to look at how to lay out the network, we spent many, many hours thinking about this. Our objectives were very simple. We wanted to be able to quickly deploy services, obviously, and we wanted to be able to pivot on a dime pretty quickly and also be very cost effective. Being in healthcare, we have to be very conscious of our customer data, and so we have lots of security constraints, audit controls, compliance, and those kinds of things. So having protections in the network was absolutely critical to us. So what we want to try and do is use a centralized team that's well skilled in doing all that network security and not distribute that knowledge throughout the organization. So still keep our centralized network team, but then let a distributed method for all our DevOps teams. And with that distributed DevOps teams, we get accountability both at the code layer and at the cost and security. All those components are there. I'm not saying this well. In GCP, one of the biggest advantages that we found was the notion of a host project and the service project. So you'll see that we have a couple host projects and then we use lots of service projects. With the lots of service projects, we can delegate those down to the development teams, and so they're fully accountable for what they're going to do. But we don't want them to have to worry about all those network pieces. So how do we do that? So our approach was very simple. We set up 2 host projects, and we have interconnects connected to those host projects. They're connected to routers and Equinix and that kind of thing that go back to on-prem and to other cloud providers. And each one of those have multiple different networks in them, multiple different VPCs. But we don't share all those networks with the service projects. Some of them are used just for networking purposes. We have hundreds of service projects. the service projects are bound to a single host project. That may sound restrictive, but it actually is a very good thing. So therefore, you have a service, if I'm a developer, I have a service project for my production applications. I have a service project for my non-production applications. And as you well know, projects are a bound of cost as well as authorization. So I can give authorization differently in a production service project versus a non-production service project. And then we advertise or grant the permission, the permissions there, compute network use. We grant permission on a selective basis so that this subnet is authorized in that service project. What that does for us is that the application developers don't really need to think about which subnet to use. We might advertise two. One's in US East 1, one's in US Central 1. And so you have a choice. Which region do I want to run in? There's not a lot of thought process about IP addresses and routes and all those kinds of things. And that's good because we have a highly dispersed development teams or DevOps teams that have a wide range of skills as well. And in some cases, you start mentioning IP and routing and that kind of thing, and their eyes glaze over and they don't want to hear it. I think we've all had experience with that. So whenever we try and do this, we're trying to make it as simple to consume as possible for those DevOps teams. And it's constantly a challenge to do training and education and documentation. So there's never enough of that. You're going to repeat yourself over and over and over again, but that's not because of the networking, that's because of the organizational challenges that you have in a large multinational organization that's ever changing. But we also have the governance controls, as Neha was saying, that within, for example, VPC flow logs and the firewall logs, they're in the host projects, so we can actually monitor those. We guarantee that those get to the appropriate monitoring methodologies, so therefore they can be alerted and controlled and archived the way they need to be. So again, we have a small collection of network experts that manage a few projects. So all the things you got to worry about, interconnects and VPNs and peering and cloud routers and all this kind of stuff that we all know and love in the network world. Only a few people really need to know that. And we do deploy some centralized appliances for ingress and egress. You can think that we're taking things from on-prem to the cloud, and we have built into some of those appliances particular functions, and we had to bring those with us into the cloud. We're trying to move quickly into the cloud, and we have to enable that. And so the VPC methodology has allowed us to do that. We create those new subnets. We can create new subnets. For example, I had one where there was a project needed an extra subnet just for that project for a very specific purpose. So you're able to create that subnet, grant permission to that subnet just to that project. No other project sees it. It's just for that purpose. We have centralized firewall management with self-service in the fact that we use three different portions here. This is the GCP firewall. The first is that we're using service count to service count. Neha showed some service count to service count, so your VM instances or Kubernetes clusters have service counts that they run as, and we set up firewall rules. When we create a project, we create some service counts for them, and that's what they deploy on. And we create these firewall rules so that anything, an egress and an ingress rule for that firewall, for that service count, so it can talk to itself. So everybody on that service count can talk to each other just fine. What that means is, as a consumer, for a developer, if I'm using a service count, I know that any other instance on that service count has open firewall access. So they don't have to say, "Mother, may I please open a port," or anything like that. The second one, which was really quite innovative and we found has been very powerful, is to use network tags. Now, one notion about network tags is that a network tag can be applied by anybody at any time on any VM. So what we wound up doing is we said, okay, these are opt-in tags. So therefore, for example, we have one that's internal web server. And what internal web server does is it allows 80 and 443 on 10.00/8, whatever, on the internal networks. And so therefore, if I am exposing an internal web server and I want to grant it to everybody on the premise, then I can just apply that one tag on my one server, and therefore I've granted it. So through security, it takes some negotiation, but through security, we've granted certain patterns that are approved, and I, as a developer, can apply that tag, and I immediately get that access. We also have instrumented several cloud functions and other methodologies to look for aberrant behaviors. If somebody tries to create a firewall rule, even though it's in the network team and they're supposed to know better, if they create a firewall rule that has 000, you don't really want to see that, so we immediately disable that firewall rule. And I tripped right into that myself because I was in one of the areas and I opened up 0000 and disabled within about 2 seconds. And I said, why is that disabled? I re-enable it. Just, oh yeah, I know why. Okay, so everybody, that's one way we enforce compliance. So again, the value of service projects is very simple. We get accountability, specifically fiscal and accountability of responsibilities. One of the things that we found historically has been that disaster recovery and high availability and all those kinds of things are considered a infrastructure problem. Well, if you really think about it, high availability, disaster recovery is an application problem. That's where it should have been all along. And so we're trying to move that responsibility back into application development teams. Again, this is a training exercise, documentation, education is necessary. I mentioned about the small set of visible subnets to the service project, and typically those are regional. In some cases for north-south traffic, we have some additional subnets. And we use service counts for east-west and opt-in tags for some north-south. So therefore it's pretty much self-service. If there's something outside those bounds, then you have to make a request, and then those get provisioned for you. And if it's outside an expected parameter, there's some negotiation, obviously, that goes on. We've also implemented organizational policies that prohibit any VM instance from having an external IP address. So that's flat across the board. You cannot create an instance with an external IP address. It provides obvious protections. So as an illustration similar to what Neha had, in our case we have multiple different regions, we have multiple different VPCs, and across different host projects. I might have a service project that's connected to one, talking to another through that global network. And what I did on this slide, on the right-hand side, you'll see the firewall rules. The first one on there is a tag-based rule. So if I apply my tag-based rule, I'm going to have that tag on my instance, and the source range would be 10.0.0.0/8. And the second one is my service count to service count within my own service count. I can talk to myself on anything. And then the last one is one service count talking to another one on a special hot board. Okay? So that's pretty much what we've done. It's worked really quite well. We've been running that for about 1.5 years now, and it's been pretty successful all the way through.